Now we've covered all the skills that you now need to be able to do, understand and be able to work with when it comes to circles at higher level mathematics. What I'm going to do in this video, I'm going to present to you 3 past paper questions. I want you to look at the past paper questions, think about them, pause the video and have a crack at them. They'll test all the different skills, or the majority of them at least, that you need to be able to work with effectively and efficiently in order to be able to score as high as possible in this section of the exam when it occurs. Here they are. So I've got 3 questions here. The first one is about looking at the equation of a tangent and thinking about the properties associated with that in circles. The second one, I've given you an equation of a circle and I want you to determine a range of values such that it can exist. You'll see exactly what that one means when you start to think about it. And the last one is a combination of looking at distances between centres, equations of circles and lines of intersection as well. So that one will tax you a wee bit too. So pause the video and have a crack. So the first one, I've got a circle, there's its centre at 1, 2. It has a tangent touching at 3, negative 1. What is the equation of a tangent? Now remember, to get the equation of a line we need 2 things. We need the gradient m and we need the point AB. Now the point we've got, it's just the point here, t, where it meets at 3, negative 1. We need to get the gradient. Well, one thing you have to remember, if you have a radius from C to T, what you know is that the gradient of that line there is perpendicular to the gradient of the tangent. What that means is I can use the property m1 times m2 equals negative 1 to get the gradient of my tangent, and I've got everything I need for the equation of my line. So the gradient CT, what I can do to calculate that is use the classic formula y2 minus y1 over x2 minus x1. I get 2 take away negative 1 over 1 take away 3. 2 minus minus 1 is 3, 1 minus 3 is negative 2, so my gradient there is negative 3 over 2. I then use m1 times m2 equals negative 1 to get the equation of my tangent. So my first gradient, the gradient of CT, is negative 3 over 2, so it's negative 3 over 2 times my tangent's gradient equals negative 1. So my second gradient, i.e. the gradient of my tangent, is 2/3. Substitute it all into your y minus b equals mx minus a formula, and we've got our equation of our tangent. So y minus b becomes y minus minus 1, minus minus becomes a plus, so it's y plus 1 equals 2/3 bracket x minus 3. Multiply out, simplify and get it into the general equation of a straight line form. Multiply by 3 to get rid of it and we get 3y plus 3 equals 2x minus 6. Shift it all over here, we get 3y minus 2x minus 6 over here becomes a plus, plus 9 equals 0. So there you go, equation of our tangent in the form of a general equation of a straight line. Second question, given that this represents a circle, determine the range of values of p. So we need to figure out the condition on p, or conditions on p, that allow us to say the circle exists. Well, the biggest thing that you have to remember for a circle to exist is it has to have a radius bigger than 0. Now remember, the formula for the radius is r equals the square root of g squared plus f squared minus c. So what that means is the bit in the square root, the g squared plus f squared minus c, has to be bigger than 0 for it to exist at all. What we now need to do is find g, f and c, substitute them in and solve it. So I know that 2g, just from the equation, is negative 2p. I know that 2f is equal to negative 4p, and I know that c is equal to 3p plus 2. From these I could say fine, so g is equal to negative p, f is equal to negative 2p, substitute them in. So I get negative p squared plus negative 2p squared, take away c, which is take away the 3p plus 2, and I know it's got to be bigger than 0. Multiply out and simplify, so negative p squared is just p squared, negative 2p squared is 4p squared, so I've got 5p squared, take away this bracket, so take away 3p minus 2 has to be bigger than 0. Now remember, to solve a quadratic, we simply factorise it and see what satisfies that. So if I factorise this side here on the left, I get 5p plus 2, p minus 1. Now that I've got that, I can say that has to be bigger than 0. Now I can use this to get the conditions which satisfy this equation here? Well, it's bigger than 0 and I've got two things multiplied together. So there's two things that can happen here. Both have to be positive or both have to be negative. The signs negate each other and it's always a positive answer either way. So either 5p plus 2 is bigger than 0 and p minus 1 is bigger than 0, or 5p plus 2 is less than 0 and my p minus 1 is also less than 0. So let's have a look at these. From this I know p has to be bigger than negative 2/5, or p has to be bigger than 1, and here I could say p has to be less than negative 2/5, or p has to be less than 1. Let's look on this side here. So p has to be bigger than negative 2/5 and bigger than 1. Well, if I do this and I say, for example, p is equal to 0, I get a positive bracket and a negative bracket. Multiply them together, I get a negative answer, so it doesn't work. So p can't be just bigger than negative 2/5. But if I go a bit further and say it has to be bigger than 1, so let's say p is equal to 2, I get a positive bracket and a positive bracket, which gives me a bigger than 0 answer. So that is one of the conditions I have to satisfy. If I then look over here and say, right, I've got negative 2/5 and 1 again, but it has to be less than these. So if I go for this one and say it has to be 0, because that's less than 1, again, positive and a negative gives me a negative answer. Doesn't work. But if I then go less than negative 2/5, so let's say negative 1, I get a negative answer here, and that gives me a positive final solution. So I could be there as well. So I get two conditions p can satisfy. So I can then say either p is bigger than 1 or p has to be less than negative 2/5. Could be either of these two scenarios and the equation of the circle will exist. And our circle will be there when we calculate the equation. The final question I set was this one here. So I've got three parts to it. Writing down the centre and radius of a circle with this equation. Second equation here, calculating distance between the centres of the two circles, showing they intersect. And then the line with the equation y equals 4 minus x, common chord, find the point of intersection of the two circles. So let's start with part A. Write down the centre and radius of the circle with that equation. Well, I know my centre is given by negative g, negative f. And if I look at the equation, remember, there's your 2g, there's your 2f. So if 2g is 8, g has to be 4, which means that this part has to be negative 4. 2f is equal to 4, which means f is equal to 2, so my negative f is equal to negative 2. I can then calculate the radius using the formula we actually mentioned in the previous question, square root of g squared plus f squared minus c. Now c in this case, remember, comes from that final part there. So I get the square root of g squared, so 4 squared, plus f squared, which is 2 squared, take away negative 38. So 4 squared is 16, plus 2 squared is 20, 16 plus 4, minus 38, so it's plus 38, so I get 20 plus 38, which is equal to the square root of 58. So that's my first part, that's part A. I've got my radius, I've got my centre, I'm sorted. Second part, I've got a circle here with its equation. I want to find the distance between the centres of these two circles and show they intersect. Now remember, for the two circles to intersect, D, the distance between the two centres, has to be less than the two radii added together. If this is the case, they intersect at 2 points somewhere along the way, and they look something like that. So I need the centre and the radius of this second circle. Well, I can read off the centre. The centre is simply given by 4, 6. And I can read off the radius because I know that this one here is r squared. So if r squared is 26, the radius is equal to the square root of 26. So now what I can do is calculate my distance and see how it compares. So for this one, I know my distance is equal to the square root. Again, it's the x1 minus x2 squared plus y1 minus y2 squared of the two centre points. So it's the square root of 4, take away negative 4 squared, plus 6, take away negative 2 squared. So 4 minus 4, 4 plus 4 is 8, 8 squared is 64. I've then got 6 minus 2, which is 8 again. Again, 8 squared is another 64. So that then gives me the square root of 128, which is the equivalent of 8 root 2. So that's my distance between the two centres. Now at this point it's probably useful to think of it in terms of decimal anyway, so what we could do is say that that is equal to 11.313, and then it continues on. What I now need to do is add my two radii together. So I need to do R1 plus R2. What that then ends up giving me is root 58 plus root 26. And if I plug that into a calculator and do it, what I'll end up getting is 12.774, and then it continues on as well. So what I can do is look at that and simply say, therefore, D is less than R1 plus R2, so therefore the circle's cut at 2 points. The circles cut each other at 2 points. We've satisfied the condition that we want. Now the last part, the line with equation y equals 4 minus x, is a common chord passing through the points of intersection of the two circles. Find the coordinates of the points of intersection of these two circles. Now, the best way to visualize this one is to actually sketch a diagram and have a think about it. So what it means by common chord, if I have our two circles here, it's a common chord passing through the points of intersection. It's a straight line that cuts through there. So it wants to find these points here where essentially the two circles in the line meet, so all three are common together. Now if I take the equation of this line and substitute it into the equations of the circles, I should be able to find these 2 points. Now, it doesn't matter which circle you substitute it into. You should still get the same answer regardless. So let's take this one here. So I'll end up with x minus 4 squared plus, now in this bracket I'm going to put this in instead of the y. 4 take away x minus 6 squared equals 26. So what I need to do now, multiply these brackets out, write it as a quadratic, and I can solve this for x. So if I multiply this bracket out, I get x squared minus 8x plus 16. I then get plus, and then this bracket multiplied out, well 4 minus 6 is negative 2. So I get negative x squared, so that gives me x squared. I've then got negative x times negative 2, which is 2x, and I do that twice. So I get plus 4x. I've then got negative 2 squared plus 4, and I'm going to shift the 26 over, take away 26 equals 0. Simplify this side and solve it and see what we get. So we get 2 to the x squareds. I've then got minus 8x plus 4x, so that then gives me minus 4x. I've then got 16 plus 4, which is 20, take away 26, which is minus 6, and that equals 0. Factorise it off and I get 2 bracket x squared minus 2x minus 3 equals 0. So 2 bracket x minus 3 x plus 1 equals 0. And from this I can simply say find so x equals 3 or negative 1. Using these and substituting them in here, I can find the y parts of the coordinate. So if I have x equal to 3, 4 minus 3 gives me 1. And if I have x equal to negative 1, 4 minus minus 1, 4 plus 1, which is 5. So I can then say, therefore, the points of intersection are given by 3, 1 and negative 1, 5. That's where the two circles and that line all meet together. These are the types of question, and this is the difficulty you're looking at getting when it comes to circles. We need to be working at this standard and remembering all the different aspects of the topic that we've been taught. So that's all your different properties of general equations of a circle, your properties of radii, your 2g, 2f part, and how we look at the intersections of circles and how we can prove it based on the distance being compared with the two radii and the different characteristics of that.